Hello everyone, welcome to iitiansgateclasses. My name is Dheeraj. So I'll be teaching you the analog electronics. For analog, this is very scoring subject. Around 15 to 16 marks of questions are asked in electronics and communication. For electrical, it is around 5 to 6 marks. So these are the topics that will be covered as part of analog electronics. First basic topic is a diode, followed by BJT, then FET, after operational amplifier, then feedback amplifiers, and at last there is oscillator. So we will be covering these all the topics one by one in the class. But as this is the demo presentation, so I will be briefing you for the basics of diode and which kind of questions are asked in the gate exam and how to solve them. Most of you must be knowing the basics of diode, how it works. So on the left hand side, this is the schematic of the diode. This positive terminal is called the anode and this negative terminal is called the cathode. How diode works: when the positive terminal potential becomes more than the negative terminal potential by cutting voltage, then diode turns on and the current flows through it. We can see in the IV characteristic of the diode, once we start applying the voltage VD, still current is very small. So after one voltage, which is V diode or the cut-in voltage of the diode, the current actually starts flowing because after diode voltage becomes more than the cut-in voltage, the diode becomes on and the current starts flowing through it. And similarly, if we give the negative voltage to the diode, it becomes off till this point. But after a certain point, the current starts flowing. This point is called the reverse breakdown voltage. So what is the value of V diode or the cut-in voltage of the diode? Its value is zero point 0.7 volt for the silicon based diode and zero point 0.4 volt for the germanium based diode. In the gate question, until and unless the value of the cut-in voltage is not given, its value is assumed to be zero. And if in the question it is given that the diode is ideal, then also the cut-in voltage will be assumed to be zero. So we will see that how diode behaves in the DC circuits. So whenever you see the questions in which diodes are used in the DC circuits, which mean to say that circuit is having the DC power supply, then what will be behavior of the diode? In that case, diode behaves as a power supply in series with a resistor. So the power supply of the this power supply, its value is actually the cut-in voltage of the diode, and this is the diode resistance which comes in series with the power supply. So in the gate questions, the value of RD is not given and it is assumed to be zero. And the value of V diode is again, it is 0.7 volt for silicon, zero point 0.4 volt for germanium. And if there is no information is given for this cut-in voltage, so its default value is zero. Also in the gate question, if it is given that diode is ideal, then also the cut-in voltage will be assumed to be zero. Moving on, so we will solve a circuit which is consisting of diodes and a DC power supply. So first of all, this is a question of that kind, diodes at DC. Why it's diode at DC? Because there is a diode and some resistance and a DC power supply. So this question is of category diode at DC. So we will see that how to solve this kind of questions. So we will solve this question step by step. So whenever you see a question of the type diode at DC in the gate question, so first step is always that you start with is they have to assume that all the diodes are forward biased. And then the step 2, after considering that all the diodes are forward biased, then you have to in the second step you have to apply the KVL or KCL or any other network theorem that you have learned so far in network theory. You have to apply all those any of those techniques to calculate the answer. Once you calculate the answer, the step 2 will be over. Then you have to go ahead on the step 3. The step 3 is basically verification, because in the step 1 we have assumed that all the diodes are forward biased, but our assumption might be wrong. So in the step 3 we have to verify our assumption that if it is a true or false. Now we can have two ways, right? Our assumption might come as a true or might come as a false. So if our assumption comes, if in the step 3 we verifies that our assumption is true, so which means the answer you have calculated in the step 2 is a correct answer. And if the assumption is false, then which means the answer that we have calculated in the step 2 is a false answer. So then we have to again go to step 1 and we have to change the assumption. So we will these are the basic steps to solve the diode at DC. So now we will solve this circuit step by step. So first of all, thus we will follow the step 1. In the question, it is given the diodes are ideal. So which means the V diode or the current voltage will be assumed to be 0. And there is no information about the diode resistance. So that value will also will be considered as 0. Right? So we will solve this question step by step. So first step is that we have to assume that all the diodes are forward biased. If the we are assuming that all the diodes are forward biased, so it will be so as you can see, the diode is replaced with a single wire. Why? Because V diode is also 0 and diode resistance is also 0. So in that case, we can replace a diode with a single wire. So by the assumption that all the diodes are forward biased, the circuit will become like this, right? So this is our equivalent diagram in the step 1. Once completing the step 1, yeah. So after completing the step 1, we will come to step 2. So which is we have to apply the KVL, KCL or any other network theorem that you have learned so far to calculate the answer, right? So here, what's the best way to me looks for to apply the KCL at the node V naught, right? So how to apply the KCL? So we can say I1 plus I2 will be equal to I3, right? So what will be I1? So I1 will be V1 minus V naught divided by 1K. So here I have written, so V1 minus V naught divided by 1K plus I2. So what will be I2? It will be V2 minus V naught divided by 1K is equal to I3. So what will be I3? It will be V naught divided by 9K, right? So in the question, the values of V1 and V2 are given to be equal to 10 volt and 5 volt. So having these values, we can calculate the value of V naught, which is equal to 7.1 volt. So which is the answer? So before judging this answer to be true or false, we have to go to the step 3 and we have to verify the assumption. So let's go to the step 3 and let's verify the assumption. So what was the assumption in the step 1? It was that all the diodes are forward biased, correct? So now we'll verify. So this is D1 and this is D2, right? So for D1 to be on, the anode potential should be greater than the cathode potential. So condition for diode D1 to be on is V1 should be greater than V naught. Now we'll check whether really we are meeting this condition or not. So V1 is given the question and this is 10 volt and V naught we have calculated which is 7.1 volt. So with these two values, we can say that V1 is greater than V0, right? And this is what we have the condition also for the D1 to be on. So we have verified that D1 will be on, right? So now we will judge for the D2. So condition for D2 to be on is V2 should be greater than V0, correct? Because D2 to be on also, the anode potential should be greater than cathode potential. So V2 in the question is given and is equal to 5 volt, and V0 we have just calculated at is 7.1 volt. So having these values, we are seeing that V2 is less than V0, right? So it is less than V0, but to be on, V2 should be greater than V0, right? So these two things are contradicting. So which means that D2 is not on and it is off, correct? So which means that with this contradiction, D2 cannot be on. While in the step 1, we have assumed that both D1 and D2 are on. But now with this assumption, with this verification, we have come to the conclusion that D1 on but D2 is off, right? So which means our assumption is in the step 1 was false. So which means the answer that we have calculated in the step 2 is a wrong answer. So it means we have to change our assumption and we have to calculate the answer again. So what we will do, we'll go to the step 1 again and we will change our assumption. So what will be the new assumption? It will be assume D1 is on and D2 is off. This is our new assumption. So based on the new assumption, we can draw the equivalent diagram, right? So D2 is off, so we can replace this with a open circuit, right? So that's why we have not shown here, because if D2 is off means it is an open circuit, so no current will flow in this branch. So we have just open it, right? And D1 still we assume to be on. So D1 again will be replaced with a short circuit wire, right? So this is step 1. So step 1 is we have done. Now we'll go to step 2 and we will calculate the answer. And the answer is V0, right? So again, to calculate the V0, we will apply the KCL at the same node. So now the KCL will be I1 will be equal to I2, correct? So what is I1? I1 is V1 minus V0 divided by 1K. So V1 minus V0 divided by 1K is I1 is equal to I2. I2 is V0 by 9K, right? So having the V1 is equal to 10 volt, we can calculate the value of V0, right? So V0 is equal to 9 volt. So in the step 2, now we have calculated the answer. Now we will move on to the step 3 and we will verify the assumption again, correct? So this is our original circuit. So we will verify first for the D1. So D1 to be on, V1 should be greater than V0, correct? So V1 in this question is 10 volt and V0 is 9 volt. And we can see V1 is again greater than V0. So it is meeting the condition. So it means D1 is on, correct? So now we will see for D2. So we assume that D2 will be off, right? So what is the condition for D2 to be off? That V2 should be less than V0. Why? Because if D2 has to be on, the anode potential should be less than the cathode potential. Now we will see, are we really meeting this condition or not? Now we can see the V2 in the question is given and is equal to 5 volt, and V0 that we have calculated is equal to 9 volt. So by this we can say yes, V2 is less than V0, and which is our condition also for D2 to be off. So in this assumption, D1 is on and D2 is off, and which is our assumption as well. So it means this is matching to our assumption. So which means that our assumption that we have that we assume that D1 has to be on and D2 is off is fulfilling, correct? So if our assumption is correct in the step 3, so which means the answer that we have calculated in the step 2 is a right answer, right? So its answer is 9 volt. Okay, so moving on. So till now we have seen that how to solve the question in the gate which are of the type diode at DC, correct? So now we will move to the case diode at AC. Like if, for example, we have AC power supply in the diode based questions, so how diode will behave in that questions. Okay, so diode in AC circuit behave as a resistor, right? So in the DC we have seen that it is replaced with a battery in series with a resistor, while in the AC circuit diode is merely a resistor, correct? And the value of that resistor is eta Vt by IDC. So we'll one by one we'll see what are these things. So eta is the emission constant or the ideality factor. So its value is 1 until and unless its value is given in the question. Its default value is 1. Right? But if, for example, in the question its value is given or 2 or something, so we have to take that value. If the value is not given in the question, we have to take it 1. Correct? So at the denominator we have IDC. IDC is the DC current which we have already calculated in the DC analysis. Okay, so in the diode DC question, we have calculated the current, right? So that this is the same IDC here. So if we have diode in the AC circuit is there, so first in the diode in AC circuit, first we have to do the DC analysis or the diode at DC, so that we can calculate the diode current, because that diode DC current will be used in the AC analysis. Correct. Then Vt is the thermal equivalent voltage, and its value is 25 millivolts at room temperature. And generally in the question, the value of Vt is given. Correct. So just we have to take the value of Vt from the question itself. Okay. Yeah. So now we will learn with the help of an example that how to solve the question of the category diode in AC circuits. Right. So if I'm saying diode is an AC circuits, so doesn't mean it is only AC. Diode in AC circuit means DC plus AC both, right? And if I'm saying it is AC analysis, so AC analysis means AC signal will be very small signal, like in millivolts or microvolts, correct? But this very small value is not enough to turn the diodes are on, right? Because to turn the diodes on, we should have current voltage, for example, some 0.7 volt or zero point 0.4 volt, right? But our AC signal is very small, like millivolts or microvolts. So that cannot turn on the diodes. So we use the DC power supply to turn the diodes on, and on the top of that we apply the AC signal, right? So I'll repeat again. So diode in AC circuit, it's not just AC power supply, it is actually DC plus AC. DC will be used to turn the diodes on, and AC will be applied on top of that. Is it clear? So in this kind of question, diode in AC circuit is already clear. It is not just AC, it is DC plus AC. So DC plus AC. So first, how to solve this kind of question? First, we have to do the DC analysis, followed by the AC analysis. So now we will learn one by one that how to do the DC analysis and then the AC analysis. So in the DC analysis, we will DC analysis same as diode DC that we have covered so far, right? So still I'll cover the points how to the DC analysis. So in the DC analysis, first of all we have to short all the AC voltage sources and open all the AC current sources if any. Okay. So basically if we are doing the DC analysis, we are eliminating the AC sources. So what is the meaning of elimination of AC sources? If it is AC voltage source, then we have to short it. If it is AC current source, that means we have to open it. Okay. And then the second step is that replace the diode with a battery in series with a resistor. As I already mentioned, the DC analysis is same as a diode at DC, right? So, if it's diode at DC, so we'll replace the diode with a battery in series with a resistor. Okay. So then the question is same as the diode at DC category only. So then we will have the same. Then we will have a same circuit as we have in the diode DC. Then we can In the step 3, we can simply calculate the DC current through the diode, right? So why in the step 3 we are calculating the DC diode current? Because that current value will be used in the AC analysis for the calculation of AC resistance. Is that clear? So once DC analysis over, we will move on to the AC analysis. Okay. So now, how do the AC analysis? So AC analysis first step is that short all the DC voltage sources. Okay, and open all the DC current sources. So this is the first step of the AC analysis. So second step is that we have to replace a diode with a small signal AC equivalent model, right? So AC equivalent model, just we have covered AC equivalent model. This is the AC equivalent model of the diode, which is simply a resistor, right? So in the second step, we have to just replace a diode with a resistance whose value will be eta Vt by ITC. Okay. So then where we have to move on to the third step in which we have to calculate the answer. Okay. So here we have discussed all the steps to solve the circuits which are of the type diode in AC circuit, correct? So now we have the same example and we will solve this question to have the better. So I will solve this question step by step. First, I will do the DC analysis for this question. Yeah. So this is our original question, so on which AC and DC supplies both are given. So this is this of the type diode AC. So in AC, you can see it is a very small, which cannot turn on the diode. So that's why we are keeping a DC voltage here. So first we have to do the DC analysis. So first step of DC analysis is that we have to eliminate the AC sources. So here we have the AC voltage source. So we will short this AC voltage source with a wire, correct? So here I have shorted this AC voltage source with merely a wire. Then second step of this question is that we have to replace a diode with its DC equivalent model, correct? So what is the DC equivalent model of the diode? It is merely a power supply in series with a resistor. And in the question, the current voltage of diode is given to be 0.7 volt and the thermal equivalent voltage is given to be 25 millivolts, correct? And here, this is the current voltage. So it is, which is given 0.7 volt here, right? And this is the series resistance of the diode, which is not given in the question. So by default, we have to assume it is 0. So we can simply replace a diode with the power supply of 0.7 volt. So here are 4 diodes and I have replaced these 4 diodes with the 4 batteries having a potential of 0.7 volt, right? So then step 2 is over. Then we have to move to the step 3. So step 3, we have to calculate the diode DC current, correct? So I have assumed that current I is flowing through this loop. So just I have applied the KVL. So after applying the KVL, I came to get the diode DC current, which is 1 milliamps, correct? So this is a diode DC current of 1 milliamps. So this value will be used in the AC analysis, correct? So DC analysis is over here. So now we will start the AC analysis. So this is in the AC analysis. What is the first step? First step is that we have to eliminate the DC source, right? So this is a DC source. We will eliminate this, and we will only keep the AC voltage source, right? Then the second step is that we have to replace a diode with its AC equivalent model. So what is the AC equivalent model of the diode? It's merely a resistor whose value is eta Vt by Id, correct? So now we have to calculate its resistor value. So in the question, there is no info given about the eta. As I already told that if there is no info given about the eta, so its default value is 1 in the question. If its value is given some, if its value is given in the question, then we have to take that value. If it is not given, then its default value is 1 and we have to use the value of eta is 1. And value Vt is given in the question is 25 millivolts And this ID is a diode DC current, which we have already calculated in the DC analysis, and we have calculated is 1 milliamps. So here 25 millivolts by 1 milliamps is 25 ohms. So we got this value of this resistor is 25 ohms. Okay, so I have this replaced this diode with the 25 ohm resistor. So all these four diodes will be replaced with the four resistors of the value 25 ohms. Clear? So then now in this question we have to find the what is the output voltage between these two terminals. AC voltage between these two terminals, right? So we will calculate. So first we'll apply the KVL in this loop. So I have assumed this I is a AC current in this loop. So I have applied the KVL in this loop to calculate the IA. So I got 10 raised to power minus 5 cos omega t. Correct? So then we have to calculate the voltage between these two terminal. We have to calculate between these two terminal. This is the one terminal and this is the second terminal, right? So this is the, so how it will be? It will be current into I into R. So I is the IA, and resistor value between these two terminal is 25 into 4 times 100 ohms. So it will be 100 into AC current. So it will come as a 1 milli cos omega t. So AC voltage between these two terminals will be 1 milli cos omega t, and that is what our answer. So this was the demo presentation. So I'm closing this presentation here. So in the main class, we will discuss more diode questions, and followed by again we'll start the new topic after diode. We'll start BJT, FET, and all. So right now I'm closing this presentation.